Hi, I'm Marty Triola, and I'm here to talk to you today about critical thinking, specifically as it applies to bad graphs. Graphs that are bad for a number of different reasons. They're deceptive in some way or another. Let's start out with a specific example. Okay. There was a study done to determine whether females really talk more than males. They got 396 participants to agree to wear voice recorders around their necks. And these 396 people wore these voice recorders around their necks, somewhat like the microphone I have on here, and it recorded everything that they said for a day. It downloaded it to a recorder. They were analyzed at the end of the day, and the number of words were counted. Let's look at this graph and see what they came up with. Okay, the number of males, or the number of mean words spoken per day by males, and then by females. And so here you could see that this confirms what many people believe, that females do speak many more words per day than males. Right? Well, not really, not necessarily. Let's pay closer attention to the graph instead of just looking at it and being impressed by the height of this one bar compared to the height of this other bar. Specifically, let's look at the vertical scale. Here we have units indicated, and the scale starts off at 15,500 words. It doesn't start at 0, it starts off at 15,500 words. Now, this is commonly done. Sometimes it's really necessary. You'll often see this, for example, with the Dow Jones Industrial Average. If they really want to show what's happening in a day, they'll show a graph that doesn't have an axis that starts at 0, because if it started at 0, the differences would be very slight. But they really want to emphasize the changes throughout the day. But getting back to this graph, we really do have a graph that's deceptive and very misleading. This tells me a story that's fundamentally wrong and deceptive. This story is that females outtalk males by a substantial amount. But now let's go and we'll look at this graph that's drawn with 0 at the vertical scale. Okay, so here, look at females compared to males. Okay, and here I'm starting at 0, not at 15,500. Okay, by looking at the two graphs on this correct scale, I could see that the female graph is a bit higher, but it's a tiny bit higher. It doesn't look like the difference is significant. Just subjectively, based on a comparison of these two graphs, I would say that no, it's a myth that females talk more than males. This graph is fair. The preceding graph was deceptive. Now, this particular method, using a scale that does not start at 0, very common, and it conveys a real story to us, a real moral, a real principle that we should all know and understand quite well. When looking at a graph, don't just look at the heights of the bars. Determine whether or not that vertical scale does start at 0, and recognize that if it does not, there's a potential that the tiny bit of differences could be stretched out and exaggerated a whole lot, and so that you would be misled into thinking something that's not quite correct. So don't let anybody mislead you. Analyze the graph very carefully, and very specifically know this one trick. Sometimes people do it intentionally. Sometimes people do it just to create a graph that looks good and are not aware of the fact that they're being deceptive, but they are. Don't let them deceive you. Here's another example, and this one's a bit more subtle. Okay, we've got Alaska compared to Texas. And I did a couple of things here. One thing I did, by the way, was take the names. I wrote Texas. I printed that in a much smaller font compared to Alaska. Is it proportional? I don't know. I just picked a font that was a lot smaller. And so there, I'm creating something that may or may not be true. But I'm comparing the areas of Alaska to Texas. And by using squares, I'm trying to make it easier for the comparison. But is this really correct? And if I think about comparing these two, well, this graph looks like it's a little bit more than twice as tall. This rectangle looks like it's a little bit more than twice as tall as this one, and it's a little bit more than twice as wide. So this area looks like it's roughly 6 times the area of this one. Is that correct? Well, let's go here. Okay. Now, the actual areas in square miles for Alaska, 656,000, compared to Texas, 269,000 square miles. It's a proportion of about 2.5 to 1, roughly. 2.5 to 1. Alaska's 2.5 times the area of Texas. But in the top graph, if we take this to be 1 unit wide, let's assume that this is 1 inch. I made this rectangle 2.5 inches by 2.5 inches. So this would be 1 square unit. This would be 2.5 multiplied by 2.5, which would be 6.25 square units. So this graph is more than 6 times the area of this one. But the ratio should only be 2.5. Okay, so down here I drew them correctly. Here I drew them so that this rectangle does look like it's closer to 2.5 times that area. So the moral here, even if you got a little bit confused perhaps with the geometry, the moral is that when you're working with objects of area or volume, there's a real potential to create something that's deceptive. And again, you should watch out for that. Finally, I created this graph. It's just a simple bar graph. And both bars have the same width. But I drew Alaska to be 2.5 times as high. And here I put them, I even included the scale so you could see what the actual units are. And you might agree or disagree, but in my mind, this graph, in addition to being correct, I think it's easier to read. It's easier to compare the area of Alaska to that of Texas this way. Okay, so watch out when you have areas of volume, or objects of volume or areas. Here's an example that was published in the New York Post. Going from April of one year to April of the following year, they show how their circulation grows. And they've got this steep increase, but there's absolutely no scale given. And certainly the scale does not start at 0. And if it did start at 0, this line would be a lot flatter. By drawing this line so steep, they're really creating the false impression that their circulation dramatically, radically increased, when in fact it did not. It did increase, but not by an amount that this graph would suggest. Here's a graph taken from my local newspaper. Both of these are on the same front page. They were positioned just as they are here. They're on the front page of my local newspaper. Now, on the top graph, they have school aid. And by showing this graph going up, they're showing that school aid is increasing. Here they have the state budget. The line is going uphill, the budgets are increasing. And if you compare the two lines, it looks like they're going up by about the same amount. State aid increases, matching state budget growth. But again, we should definitely not make the mistake of simply looking at these two lines and comparing them. We should look at the axes. And let's see what we can see from the axes by looking at them much more closely. For the top graph, it's in billions of dollars, and it goes from 8.5 to 11. That's a $2.5 billion gap along this vertical scale. Here, we're going from 20 billion up to 70 billion. This is 50 billion. Okay, 50 billion here, 2.5 billion up there. Totally different vertical scales. Let's look at the horizontal scale. This graph starts out at 1992 and 93. This graph starts out at 1982 and 83. They don't even start at the same time. Although the graphs look comparable, they're not. Finally, if you look at it even closer yet, look at this particular point. They identify this point as 71.9 billion. But on this vertical scale, this is 70 billion right there. This is the line for 70 billion. And if you go across, what they indicate as 71.9 billion is below that. So something is wrong here. They made a mistake somehow. So looking at the vertical scales, the fact that they're so different, the timelines are different, there's a fundamental mistake. And this is on the front page of a large newspaper. Horrible, terrible graphs. The basic moral is to not simply form any kind of a conclusion or develop an impression by just subjectively, superficially looking at the shapes of the two graphs. We should really look at the scales very carefully. Think of everything as comparable as they should be. So the main objective of this section is to really look at a few different examples of this type, to really develop the idea that we should analyze graphs. Don't look at them superficially, but analyze them very carefully. Don't be misled by deceptive graphs. And really think about that very first example with the axis not starting at 0. By not starting at 0, you have a real potential for creating a graph that's very deceptive. And throughout the course, later on in the textbook, you will find examples of cases where that's used, and you'll be asked to interpret the graph, to think about whether or not anything is wrong, or what could be done to correct the graph, to make it a better representation of what it should be doing. So critical thinking, analyze it. Don't look at graphs superficially, but analyze them, think about them very critically. So that concludes this section, and focus on your critical thinking skills, and good luck. Thank you.